Alright, good evening guys. We're going to go through this kind of quick, but you've got 3 example problems with me tonight. We're going to talk about, we talked about in class, exterior angles, what they add up to, how they're related to their interior angles, and we're going to go through some problems that involve that. Tomorrow in class you're going to have a bunch of practice problems involving just exterior angles with regular polygons, with irregular polygons, how they relate to interior. Just a lot of practice problems, okay? So I want you to watch this one, pay attention, and you should be good to go for tomorrow. The first problem you see, it says find the measure of each interior and exterior angle. We've got a few algebraic expressions for our exterior angles. Just like when we did the interior ones, we can add them all up, and I hope we all remember exterior angles always add to 360. It does not matter the size or the shape, how many sides, it doesn't matter, they're always going to add to 360. Okay? So first thing I'm going to do is solve for r. So I'm going to add these up. So I have 4r plus 8r plus 5r minus 1 plus, oh, that was an equal sign. Hang on, let me work on my typing here. 5r minus 1 plus 7r minus 1. That is all equal to 360. Okay, so there's my setup of this problem, the first part of it. From there, I need to combine my like terms. So I have 8, 4, 8, that's 12, 17, I see 24r. And then positive 1 and negative 1. Oh good, those cancel. I like it when that happens. So 24r is equal to 360 degrees. So all I did was combine my like terms. Alright, from there, I am going to need to divide by 24, right? Let's see if I can draw this very well. Not very well at all. Divide both sides by 24. And when we do that, we find that r, in fact, equals... Anybody know? Yep, r equals 15. Now, keep in mind, they didn't ask me to solve for r. It asked me for the measure of each interior and exterior. So we need to take that, we got to plug it in to every exterior angle. Now, how are we going to find the interior ones, right? Well, let's go through this. Let's check this bottom left corner over here. I can plug 15 in for the r down here. So I get 8 times 15. And that's going to give me... Anybody? Anybody? Really? Silence as we don't know what 8 times 15 is? How about 120? Beautiful. So this angle right there is 120 degrees. That is our exterior angle right there. Angle DML or DMC, because we all like some Run DMC. If you don't know who Run DMC is, then I feel really old, by the way. To get the interior angle, we talked about today how this interior angle and this exterior angle, this pair here, is very, very special. What we pointed out was that, hey, they form a line, which makes them a linear pair, which in fact makes them supplementary. So we're going to take 180 minus 120, which I hope we all know, by the way, is equal to 60 degrees. And that is the measurement. That is how big that interior angle is. Now, I know on the picture, right, that interior angle looks obtuse. But remember, don't trust your eyes. When you're given algebra like this, don't trust your eyes. This was just me, honestly, not planning ahead and not making my picture look all pretty, because I drew it kind of quickly, all right? You would do that for every pair. I'm not going to waste all your time tonight in showing you that. You just plug 15 in to get the exterior. You subtract from 180 to get your interior, okay? So that is one kind of problem you're going to be facing. Another kind of problem, and these two are the next two are kind of similar. This one says, can a regular polygon have interior angles that each measure 112 degrees, and justify your answer? So my first thought is, oh, interior, that's n minus 2 times 180, right? I know that formula. I'm really excited that I know that formula. But what does this problem not tell us? Why can we actually not use this one? What do we need to know in this formula? Yeah, to do this formula, we must know the number of sides. Notice this one simply says regular polygon. So as much as I like my n minus 2 times 180 formula, Can't use it, right? But what I can do, right? What do I know about other angles in any polygon? And I hope you said out loud that exterior angles add up to 360. It does not matter what type of polygon it is, which is great for this problem because I don't know what kind of polygon this is. Okay, so now the next question is, what does this 112 have to do with anything? Well, if the interior angle should all be 112, what should each exterior angle be? So I want to know, what should each exterior angle be? And I hope you're all thinking to yourself, well, hey, I know an interior and its exterior angle are supplementary. So I'm going to take 180 minus the 112. And if this is regular, then each exterior angle is going to be 68 degrees. Okay? So what? So we figured out that each exterior angle should be 68 degrees. So my question to you then, let's make this a little bigger so you can see this. Alright, I know this doesn't look like any problem you've done before, but that's okay. Sometimes that happens. We know they're going to have to sum up to 360, right? So what I'm going to do is I'm going to take 360, I'm going to divide it by 68. Because what is that going to tell me? The total degrees divided by the measure of each angle. When I get this answer, which is 5.3 by the way, what is that? What is that 5.3 supposed to be? Yeah, this is the number of sides. That font is really big. Make this a little smaller. Okay, the number of sides. So, I'll walk you through what we did, and let's see if we can kind of come up with an answer. The question we want to know, can a regular polygon, because it's regular, that's why we can use this division down here, this last step we did, because regular means when we divide it, everything is the same. Can a regular polygon have interior angles that each measure 112 degrees? So we said we have to deal with exterior, because since we don't know how many sides this has, we don't know our n, we can't use interior angles. So we deal with exterior. We say, well, if each interior is 112, then each exterior would be 68, since they're supplementary. We took 360, we took the total, divided by the measure of each, and that gave us the number of sides. Now here's my question to you. Can any polygon have a decimal as a number of sides? Can you have partial sides? And you're right, you can't, right? The idea of a polygon, and you can see up here, all of these being polygons, they all have 4, 5, 6, 7, 12 sides. You can't have, even if it's concave, there are no partial sides, right? If I'm thinking of a partial side, I'm probably going to think of something that looks like, like that makes me think of partial sides, you know, that it's not closed or things overlap. So my answer to this problem is a no, right? And the reason is because polygon can't have partial sides. And that's what that decimal says. That 5.3 says that if this were true, if each exterior angle is 68 degrees, then we'd have 5.3 sides. And that just does not make any sense. Okay? So this one's kind of weird. There's no good, like, pattern to this, if you will. Just kind of how we had to think through it. This is very much a thinking kind of question. All right. I said I would keep it under 10 minutes, but I'm going to do one more with you real quick. It's kind of similar. So it says the interior angles of a regular polygon each measure 108 degrees. How many sides does the polygon have? Okay, so I'm going to say my idea. We don't know how many sides. In fact, that's what it wants us to solve for n. It wants us to figure that out. There is a way to do this with the n minus 2 times 180 formula, but it's so much easier at this point to do it with exterior, right? Each exterior is going to be 180 minus the 108, which is 72 degrees, right? So this is the measure of each exterior angle. And just like we just did, we take the total, because exterior angles are always 360, and divide by 72. That gives us 5. if you do that math on a calculator or in your head or on paper. Okay, so what is that 5 again? What does this stand for? Yeah, this is the number of sides. So this is a 5-sided figure. A 5-sided figure is going to have 108 degrees if it's regular for every interior angle. What type of shape is 5-sided? I hope y'all just yelled it very loudly. It is a pentagon. Okay, so the idea being, if I don't tell you how many sides it has, this one just said regular polygon, the last one just said regular polygon, you're stuck working with the exterior angles. So you may have to use something with 180 because they're supplementary. They always add up to 360. That is your show for the night. Have a good night.